This is the Building Automation Monthly Podcast with Phil Zito, episode 86. Hey folks, Phil Zito here, and welcome to episode 86 of the Building Automation Monthly Podcast. And in episode 85, which is one episode back now, I told you how I finalized my new course, Design for Building Automation System Professionals, and how it's currently being reviewed by my early access customers. Well, in my effort leading up to the launch of the course, I'm going to be rolling out several episodes about designing a building automation system, because that's a topic that I just don't see being talked about. I don't see being taught. I don't see people really covering that. So consider this my super stealthy way of drawing awareness to the problem of how to design a building automation system and then pointing out that my course can fix it. Because, I'm ninja like that, so. Anyways, but for those of you who just tuned in and you're wondering who this crazy guy is talking to you, and maybe this is your first time listening to the podcast, my name is Phil Zito, and I run the Building Automation Monthly Podcast, or BAM as we in the BAM Nation like to call it. And in today's episode, I'm going to be taking you through the ins and the outs of building automation system design. The inputs and outputs, that is. By the time you finish this episode, you'll know exactly what the inputs and outputs of a building automation system design are. And this is really important because even if you are in no way, shape, or form involved with designing a BAS, this information is going to help you out. Now, you may be like, okay, how? How is this going to help me out? Well, really, it's really simple. Think about it, okay? If you're in project management, you're not designing a BAS, you're just project managing a job. Understanding the different phases and inputs and outputs expected for a design is going to help you know kind of where your project's at, what is being produced, what needs to be produced, those kind of things. If you're in sales, this information is going to help you because you're going to know what your operations and your designer need in order to produce a design, and then kind of what you're going to get out of it. If you're an engineer, maybe a facility operator, or maybe you're in consulting, understanding the ins and outs is going to help you when you're reviewing documentation. It's also going to help you when you're seeing documentation being delivered during a project. You're going to understand what this documentation is, and more importantly, what it should have, what it should maintain. All right, so that's enough about that, right? Let's dive in. Now, before I dive into the inputs, I need to clarify that there's really two types of designs, and those are designs for new buildings and designs for existing buildings. And depending on the type of design you have going in, you're going to have different inputs. And so here are the inputs you're going to have regardless of project type. Those are going to be mechanical, electrical, and plumbing plans, specifications, and scope of work documents. Let's go through each one real quick. So mechanical, electrical, and plumbing plans, also known as MEP plans or MEP drawings, what they are, they're a set of drawings, usually 24 by 36, laid out that show you several different things. They're going to show you a floor plan and show you where the mechanical equipment is placed. They're going to have what's called a schedule. And that schedule is going to describe the equipment that's being included, where it's serving. It's different parameters, like for a VAV box, how much CFM, if it has heat, those kind of things. It's going to have installation notes. So-and-so needs to include this. Like, for example, dampers provided by controls manufacturer, installed by mechanical manufacturer, or something like that. And then it's going to have system diagrams. Usually it'll have sometimes it'll have system diagrams if you get a good set of drawings. Sometimes it will have nothing, but it'll have system diagrams potentially describing how the system's supposed to be laid out, like how the central plant's laid out, how it's piped, and it may or may not be accurate, but you'll have that, and potentially you'll also have the sequence of operations. It's kind of hit or miss on that one. That's either going to be in the spec, which we'll cover in a second, or it's going to be in the MEP plans. So you got these plans, right? And you're reading through them, and it gives you all this information, essentially a snapshot of where the mechanical systems are going to be installed, what they are, how they're supposed to work, who's going to do what, those kind of things. And depending on where you are in the project, these could be very accurate, very representative of what's actually being provided, and those are called construction documents or CDs. So when you hear 100% CD, that means the drawings are effectively 100% representative of what's supposed to be installed. Or they might be like schematic drawings or SDs, in which case they're not very representative of what's going to be installed, and therein lies a problem. If you're processing SDs and building a design, which I don't know why you'd be doing that, but that's a whole other podcast episode in itself. But if for some reason you are taking SDs and creating a design and submitting that design, which I've seen happen before several times, then you could have a very inaccurate design to the point of like, hey, this schematic design has a central plant, and now all of a sudden it has rooftops with DX coils instead of hydronic units anymore. And all of your design is pretty much scrap. So it's really important to understand what drawings you're working with, what percent complete, and then what phase they're in. Next up, we have specifications. So specifications are essentially specifications. I mean, I always struggle when I'm like, how do I describe specifications without using the word specification? So specifications essentially are, they're like general parameters and, gosh, I want to say specifications, but I know I can't say that. Think about it this way. So if you were to go and pick up a car, right, you would have, your little manual that you could pick up, and it would show how everything kind of works inside it, all that jazz. That's like a set of plans. It shows like how all the pumps and motors, and this is showing my like complete ineptitude when it comes to automobiles. But it shows all the different stuff that's connected. Well, specifications are like, oh, it has 4 tires, it gets this miles per gallon, it's this liter engine, it uses this much gasoline. But it also, specifications, not only do they specify those kind of things, the general conditions, but they also specify the execution, and they specify the kind of expectations. So basically, here's how it goes. They typically will break out into 3 categories. And those categories are part 1, general, and that's kind of all the general conditions that I was just talking about. Maybe I'll talk through how the submittals are, what kind of systems, what other specifications your spec connects to, those kind of things. Then you've got products, which is part 2. And this is the typical structure. This may vary if you're outside the United States. But part 2 is going to be products, and it's going to say, well, this is the building controller, this is what it's going to be capable of, this is the field controller, this is the field trunk. These are just the capabilities of the individual products and devices. And, the sensors, they're going to be of this type, and they're going to have this kind of output, this kind of tolerance, etc. And then execution is how things are going to be executed, how you're going to go and do the work, how the work's going to be coordinated, all these kind of things. And it's really important. And I've seen a lot of really new designers, they'll look at the plans and they'll look at the scope of work and they'll process those, but they'll skip the specification. I totally get why they do it, because I've been in their shoes before. When you look at a specification, it is a block of text. It's literally this giant block of text that I swear to goodness was made purposely in this format so no one will actually read it and pay attention to it. Because, I get it. I know. I've got a bunch of engineers screaming at me right now. They're like, but it's structured and organized. You gotta have organization. I get that. But come on. Can't you insert like a freaking break in between lines or like spread it out a little bit so you can at least scan it? Maybe it's because I have ADD and I'm like, my head is in 10 million different places at the same time. But man, I just, that is something I do not wake up in the morning and go, man, I want to wake up and read a specification today. That sounds exhilarating. But no, not in the least. But the reality is, as much of a, hitting your head or hand or thumb repeatedly with a hammer kind of feeling that reading a specification is, the reality is that you've got to do it because there's so many little things inside specifications that if you don't pull them out, if you don't read them, if you don't kind of discover these things, then they're going to really get you. And this is why I see a lot of beginning designers who have all these resubmits and they're like, I don't get it. I did what was on the plans. I did what was in the scope of work, but it keeps getting rejected. I'm like, well, did you follow the submittal requirements laid out in the specification? Well, no. I mean, this is how I always do submittals. Well, that's why you're getting rejected because, and I've literally seen people be this anal, where it's like, well, you put your controller drawing before your points list, and so I'm rejecting it. And I understand that when you have, 100 different trades on a project, you've got to go and organize things so that when you list things out, your design submittals and you get them back from 100 different trades, you can combine them because they're all in the same format. So I get that. But with that being said, some people take it to a whole nother level. All right, specifications. On to scope of work. So scope of works are essentially three things, right? It's what you're going to be doing, what you're assuming is true in order for you to be doing it, and then what you're specifically excluding. So it's really important for you to review the scope of work. It's a super important input, and it's one that I think folks often don't pay enough attention to. Because it's one thing to have a scope of work that excludes something that was approved by the contractor who took your work, and you can sometimes use that as a leg to stand on. But if you are going and you've got a scope of work that it doesn't exclude something, then you can get into a lot of trouble. And also, a scope of work, you really want to look tightly at the actual scope part, the beginning part, because I've found quite often where scope of works are designed on like schematic or design documents, but not on construction documents, and the scope is completely changed. So that's something, kind of when you're doing your handoff, you want to make sure that you're sitting there and checking those things. Moving right along. So let's say you're on a retrofit project. I said there's those three that I just described, right? The plans, the specs, and the scope of work. That's going to be on every project. But let's say you're on a retrofit project. What's different? Well, it's not so much that stuff is different. It's just that there's additional things because you're working on an existing building, which naturally brings into the fold existing documentation. And this is something that I've seen a lot of folks go and execute retrofit projects and not even look at the existing construction documents or control drawings. And it kind of is just bewildering to me. Now, there's one that I understand that a lot of folks don't do, and that's called customer interviews and site walks, because maybe the customer, the contractor doesn't want to tick off the mechanical by going direct to the customer. So they're like, I can't go over the mechanical's head and actually ask the customer what might be good for them. No, I'll upset people if I do a good job. I mean, whatever. I guess if you're like that paranoid that someone's going to talk to a customer and like, I don't know what that's supposed to do, like magically make it to where you don't get to install air handlers anymore. I have no idea. But if you can sense a little bit of my sarcasm and frustration with the contracting and construction model in this podcast episode, yeah, just a bit. It serves a purpose. There's a lot of good things about it, but at the same time, it can be very frustrating when it would be so simple to just go talk to a facility director and ask them what their point and naming standard is, but you can't do that because you've got to send it through like 100 different people. And I get why, because you don't want every freaking trade going and bothering the customer. I get it. I totally get it. It'd be like if I'm building a house and the painting guy is like calling my phone and the plumbing guy is calling my phone instead of going through the general contractor. So I get it, but man, it's one of those things like, once again, we don't have to be so black and white. there's a little bit of gray. But yeah, I understand both sides of the fence. All right, back to the podcast. This podcast episode is going to have a lot of segues because I feel very strongly about this topic. And so I have a lot of opinions. All right, so existing construction documents, they're basically the plans and spec documents that I described before, but they're for the existing building. So you just really want to understand those, make sure you've got accurate representation, so if you start to affect systems, you understand what's going to happen. Really important are existing control drawings, because this is going to show you existing programming, existing sequences. Oh, if I pull out that air handler controller, well, that's going to break all of the valve reset to the chilled water supply temperature or something like that. And so I just need to be aware of the programming that's in place. So those kind of things, right? You just got to be aware of those. And then customer interviews and site walks. If you're able to do this, they're awesome because you're really able to get a lot of information. You're able to see things. And that brings me to like a little segue here before I kind of go through the outputs of the courses. You know, as a designer or as someone doing design or as someone in some way, shape, or form involved in the design process, you really have to visit the job site. I know for some of you, you're like, did he just say I should visit the job site? I mean, that's like common sense. Of course I should visit the job. But you'd be shocked how many people, like, I remember when I was running my ops team, we had this guy, we called him the vampire. And because he would work at night and he wasn't good with customers, and for several reasons, which I'll probably get fired from my day job if I talk about them on this podcast, we couldn't let the guy go. So we were stuck with this guy, and he would go, and he wasn't good with customers, so we'd have him do designs at night, and so he never visited job sites. So it was just kind of accepted that we were going to have to go and revise it based on site conditions. So you've got to be, one, you've got to make sure you don't hire people that you can't let go if you need to. But that's, once again, a whole nother podcast. But two, you've got to go and make sure that you're validating site conditions, which means at least going to the site once a week, if not, at least once every other week, and attending the job site meeting. That way you're aware of what's changing. You've got the latest drawings, you've got the latest specs, you've got the latest addendums, all of that stuff. All right. So that was a lot of stuff. And now, once you have those documents, you'll move through the design lifecycle, which I'm going to talk through that. I'm pretty sure that's going to be the next podcast episode where I'm going to talk through the design lifecycle. But out of this life cycle is going to come the design outputs. And the outputs are the ultimate goal, right? I mean, no one goes into a design and goes, I want to have inputs. No, I mean, you want to have a design come out of it. You don't want to just sit there and twirl for days. So when I'm saying design outputs, though, what am I talking about? Because there's a lot of stuff that comes out of a design, right? Well, what I'm talking about are the BAS design components. Now, there's a ton more that comes out of the design lifecycle. I mean, we're talking things like RFIs, checkout documentation, as-built, submittal packages, closeout packages, all that jazz, right? But for the sake of our conversation, and probably for your sanity, we're going to focus on the BAS design components. And those components are going to be, and here's what I see them as, right? You're going to have the title page and legend, which are kind of, they're always there, right? You always are going to have a title page and legend. And then you're going to have, network risers, system drawings, controller drawings, electrical details, and a bill of materials. So those are the 7 things that are basically going to, they're almost going to be constant. I can't think of really a project where I didn't provide all those things. I really can't think of one. Man, that's crazy. So, anywho, back to these things. Okay, so the title page is pretty self-explanatory. It says, hey, this is the project name. This is the project number. This is who it was designed by. This is the program manager or project manager for this. Now, it's really important you get all that documentation because what's going to happen is, 3-4 years down the road, Customer's going to call and be like, oh yeah, that system you installed, it decided to destroy itself. And you're going to be like, oh, that kind of sucks. And they're going to be like, yeah, and we never really kept your documentation, so I'm making a phone signal with my hand here and talking it to well, I'm like, they can't see this. Why am I doing this? All right. So anyways, so they're, they'll say, oh, well, we kind of lost the documentation. You're like, what was the project name? And then the fun begins. Did you call it by the project name? Did you call it by the site name? Did you call it by some other random name that no one knows? And this is where it gets really important that you have a naming standard for your title page. Yeah, who knew I could actually go into this much depth on a title page? But no, seriously, I mean, if you don't have that information, then it'll be really hard to find. Next up is the legend. This is kind of optional. This is where you lay out, oh, this means a wire, and this means a thermostat, and this means a controller. And I get using legends for mechanical drawings and plumbing, and maybe it's just that I'm too close to building automation. Maybe that's what it is. But I've seen some building automation packages where it was like 11 by 17 pages of symbols. And it's like, how many ways can you represent a thermostat? And I'm like, I get it. I understand that you're trying to cover like every possible symbol known to man, or maybe you're like trying to form a new form of hieroglyphics or something. But I don't get that. I don't know. I personally, I know I just said that all 7 of these should be in a job, but as I think about it, I'm like, yeah, I didn't really ever use legends other than wiring, did I? And that's right. Yeah, I would use a legend that would describe the type of wire, and it would describe the color, which would say, oh, red is backnet and blue is Ethernet, and it's 22.4 for backnet and Cat5e or Cat6 for Ethernet. And that's kind of all I would do as far as a legend. It's pretty self-explanatory. You see something that says thermostat on it, I'm pretty sure that's a thermostat. You see something that says relay, I'm pretty sure that's a relay. So, which takes us to the network riser. So basically the network riser, and this is something that's really interesting right now because it's so in flux. So in the past, you would put the supervisory device and you'd show like a line coming up and going into IT Never Never Land, and you'd say to IT closet, and that was it. And then you'd have your comm trunk that would come down and daisy chain to all the field controllers, and you'd show the address. You'd try to get the addresses in order. That way, your MSTP is more efficient, and you put the address and the controller name and maybe the location or the panel it's in. Now, though, with IP-enabled controls, you're running into things like star pattern IP, where you've got to know where the switch is, what port, because it's a direct end-to-end run from the switch port to the IP controller. So now you've got that. How do you even draw that on a network riser? That looks like a freaking spaghetti chart if there ever was one. So in that case, you've got to say, I'm going to have these design reviewers who are expecting to see a bunch of lines. But if I've got 1,000 field controllers, I'm not going to put 1,000 lines going to switches, am I? Or am I now going to start to switch over to maybe more like an Excel sheet kind of format where I'm saying, hey, here's the device and here's the switch and here's the port it goes to and this is how it's getting there? Because now you've got, so here's the interesting thing, right? So it's not just that you're running it to a switch, you're running it to a patch panel which connects to a switch, or maybe you've got a couple patch panels in between, and you may have a switch that goes to a switch. There's all sorts of craziness going on. And then you got to start to deal with VLANs and subnets and all of that jazz. So that is going to be an interesting world for a lot of BAS folks to play in, which coincidentally I have a course called IT for Building Automation Professionals that is open right now for enrollment. And you can find more information about that in the show notes. Yes, I just totally shamelessly plugged my awesome IT course. But hey, it's good, and it would be good for you. But in all seriousness, that's the deal with the network riser. which then takes us to system drawings. Now, system drawings are another thing, right? And system drawings are essentially a drawing of the mechanical system and all the components associated with that. And so what you do is you'd lay out like the ductwork, and then you put the fan and the pumps and the coils and all that jazz on it. And that would be your system drawing. And it would represent, okay, I've got these devices and they exist in this system. And you probably have a bill of material, which is a list of the different sensor types mapped back, or device types mapped back to the points, mapped back to the material and the quantity. So there's a lot to go into this, and I could spend a whole episode on each one of these, so I'm going to kind of give you a drive-by here. Then you've got a controller drawing, which is going to show the controller. It's going to show the wiring and how it's wired and where it's connected to, like what device is connected to what input. You'll typically have a points list on the controller drawing as well. Oh, and on the system drawing, you'll typically have the sequence of operations, which is a text version of how the system's supposed to perform. Then you've got electrical details. What I like to do is I like to separate my control drawings and then map the points to electrical details on a separate sheet. It makes it much more cleaner. It kind of just looks good and makes it easier to read, in my opinion. And then finally, you have a bill of materials, which this is kind of on every system drawing. You'll have a bill of materials, and as well on your network riser typically. And then your bill of materials, you'll want to keep that in an Excel sheet and keep all of the materials on like a single tab. That way you have an entire look at everything you should purchase. Otherwise, you're going to end up purchasing duplicate stuff. That's how I see jobs get out of budget, because they order the wrong stuff and it just gets all mixed up because you've got bill of material overlap, especially since you're often doing your design over several days and you may forget what you put on one bill of materials. All right, so those are all the documents. Man, that is a ton of stuff to go through. But here's the deal. While that list can seem overwhelming, it's really not that bad when you follow a process and use templates and checklists. And if you already designed BAS and you're looking to improve your design skills, or if you'd like to learn how to design a BAS or review BAS designs, then be sure to sign up on the wait list for my new course, Design for Building Automation Professionals. There's a wait list right now, and I'm only taking 40 people in the next course when I open it up. So be sure to sign up. And when you sign up for the wait list, you'll also learn more info about the course. I'm going to have a video that's going to take you through kind of what the course is all about. And then I might even throw in a surprise or two for those of you who sign up, because I'm just awesome like that. But in all seriousness, though, you can find the sign up link and information about everything else I discussed at the show notes page by going to buildingautomationmonthly.com/86. Once again, that is buildingautomationmonthly.com/86. Thanks a ton for listening. And if this stuff seems overwhelming to you, don't worry. You can learn it. You just got to apply yourself. None of this stuff is rocket science. So don't get overwhelmed. Don't let yourself mentally talk yourself out of going and doing something like BAS design, because heck, if I can figure it out, you can figure it out. All right, that's it. I'll talk to you on the next episode. Take care.